Everyone obsesses over prompt engineering, model selection, and reducing latency. But the teams shipping broken AI features share one invisible problem. They never defined what done actually means. This single oversight causes more production failures than bad prompts ever will. When you write a traditional function, completion is binary. Test pass, return value is correct, you ship and move on. But a language model never truly satisfies a constraint. It converges towards something plausible. Plausible and correct are entirely different things, and confusing them is where agentic systems break down in production. Language models can return a near-perfect confidence score on a completely wrong answer. This is one of the most dangerous properties of probabilistic systems. They dress up hallucinations in the same packaging as facts. Engineers who trust confidence scores as a termination signal are building on sand. The model feeling certain is not the same as the model being right. The instinctive response to an AI that doesn't know when to stop is to add more validation layers, more retry loops, more checks. But every new step is a new surface for failure. You end up with a Rube Goldberg machine that's harder to debug than the original problem. The real fix isn't architectural complexity. It's a clear definition of completion written before a single line of agent code. The most impactful shift you can make in agentic system design is simple. Before touching any framework or writing any prompt, write down exactly what done looks like. What evidence is required? Who or what evaluates that evidence? What happens when the evidence is ambiguous? These three questions expose assumptions your team didn't know they were making, and answering them up front saves weeks of debugging later. LangGraph, CrewAI, AutoGen, these are loop mechanics, not judgment systems. They give you the scaffolding to run an agent in circles indefinitely. They provide zero opinion on when that loop should end. Engineers who adopt frameworks expecting them to handle completion semantics discover this the hard way, usually in production, usually at the worst possible time. When an agentic system keeps producing outputs that feel almost correct, the debugging instinct is to blame the model or the prompt. Almost always, the real culprit is the absence of an explicit completion definition. Almost right is what a probabilistic system produces when nobody told it what exactly right looks like. That's not a model failure, that's a design failure upstream of any code. The teams winning with agentic AI aren't the ones with the best models or the most sophisticated frameworks. They're the ones who made termination an explicit design artifact before writing any code. If your current system is running longer than expected or producing outputs that are almost right, stop adding checks and start writing down what done actually means. That single document will change how your entire system behaves.